Okay guys, so today we are learning more on how to install solar system. Installing solar system is a technical work that requires design. So I want to give you a brief design how to do that and show you how I did my own. So we're going to talk about the solar system. The items needed include the solar panel. We need the batteries, the solar charge controller, then we need the circuit breakers for protection. Circuit breakers. Alright, then the cables. These are needed items to connect a solar renewable energy system. Okay, so for a professional work, you need all the items. Apart from the frames for battery and for panels. Now the work requires design. You must design based on the load that you want to carry. You must know how many batteries will be needed, how many solar panels will be needed to charge the batteries effectively. You must also know what capacity of solar charge controller is needed. Then you can go ahead and determine the size of cables that is needed to actually install your solar system. All of this requires engineering calculation, and so many people don't know how to do such calculations, but they guess. And more often than not, this guess does not work. Most of the things that they do, the solar installation, do fail. They do not last because they did not do proper calculations. Now, your system will be connected finally to an inverter, which will bring AC into your home or office. Inverter that will convert the power from DC to AC. The power on the battery is DC, and then the inverter converts it to AC. Alright, so this is how it works. The solar panel converts energy from the sun, solar energy, into DC energy. Then the DC energy is used to charge the batteries. Then from the batteries, the solar panel is connected to the charge controller. The charge controller takes the power to the batteries. From the battery, you take the power out directly to DC devices such as DC lamp, or charge your mobile devices using DC connectors such as USB directly, or you take the power from the batteries to the inverter, and the inverter helps you to convert it to AC. For instance, AC in Nigeria here, we use 220 volts AC. So we take power of 220 volts AC from the wall sockets for our devices, television, fans, DVD players, radio sets, and so on and so forth. But at the same time, if you know how to do it, you can go for DC devices such as lamps, television, electric iron, that are all DC, that can work directly with your 12 volt battery or 24 volt battery. So that is how solar system is designed. Alright, so the design involved is the critical thing that makes it work and last and be durable. Now, many roadside electricians, they do this work, but since they do not know how to do proper calculations, it does not work because the setting will not be properly installed and it cannot last. Alright, so today we are going to see how solar system in this house is designed and connected. I'm going to have a view of what has been done and then how it is working so far. Okay, so just make sure you watch the video to the end to see how the solar system here is connected and working. Alright, as I said, we require batteries. We have the batteries here. We have 3 batteries, each 12 volts, 100 amp hour, and the 3 of them are connected together, the red to the red to the red, and then the other side we have the black to the black to the black. The 3 of them are connected together in that manner. Reason we do this is because we are using a 12 volts inverter. If you are using a 24 volts inverter, what you need is to connect 2 batteries together in series, the red of one to the black of the other. Then, if you have 4, you connect the other 2, the red of one to the black of the other. Then you now connect the black and black of each set together and the red and red of each set together. In that manner, you will have 24 volts. And the 24 volts, we can now connect the red and the black to the inverter. Alright, but in this setup, we are using 12 volt inverter system, and we have all the red and red connected together for the 3 of them, and the black and black and black connected together also. And that makes it to be stronger to produce more current since they are all connected together in parallel. So as you can see, we see that the red, and the red all are connected together. Likewise, if you check the back here, we see the black wire here connected to the black wire over there and connected to the black wire here also. So the 3 of them are connected together like that. That is what is termed the parallel connection. Okay, now if you look up here, you see the cable coming from the ceiling there. If you look up, you see the cable coming from the ceiling, and that is the cable from the solar panel. The cable from the solar panel comes in but does not go directly to the charge controller. It's protected by the circuit breaker here. This is a DC circuit breaker that is protecting the charge controller, the batteries, from overcurrent from the solar panel. Now, the cable comes in, and the positive of the cable is entering into the circuit breaker here, and then the other side of it is coming out from the circuit breaker into the charge controller. Now, from the charge controller, we took power. Look at this cable coming down. The power is coming down from the charge controller down to the battery, as you can see. So it can charge the battery in that manner. Alright. Also, power is taken from the charge controller. As you can see, this cable here is taking power to the lamps. So all the lamps, 12 volts power is connected to them through this small changeover. If I switch it now, the power goes off. You can see this small changeover. You can see that the power goes off because the lamp over there is using 12 volts. Power taken directly from the batteries. Now, you could see the charge controller here is showing lights. By the time we switch this circuit breaker, you can see there is no more humming noise. That humming noise indicates that the battery is receiving power from the solar panel. Let me turn it on so that you can see that. Can you hear the sound? That noise, humming, is showing that power is connected from solar panel to the charge controller charging the battery. The charge controller is what is making that humming noise. By the time we switch it, the humming noise goes away. Alright. Now, in this setup, we have a second circuit breaker. The second circuit breaker is used to protect the inverter also. The power from the battery does not go directly to the inverter. We took power from the battery from here and is connected to a cable that goes to the circuit breaker here. Okay, and the power is now taken from there. Using this other cable, power is taken down to the inverter. So it's not connected directly to the battery for protection. These two devices are of great importance, very critical in this setup. Now, the first one here is protecting the system from thunderstorm. When there is thunderstorm and the solar panel receives high intensity light from the thunderstorm, from lightning, the solar panel brings high voltage and current through this cable inside. We do not want that to enter into the charge controller or the batteries. For that reason, we need this circuit breaker. This circuit breaker breaks that power because with high current reaching here, this circuit breaker will switch off itself. So the high current will not be able to enter into the charge controller and the battery. That is the first protection part. The second protection part is this circuit breaker. When there is anything wrong with the battery, whether there is a wrong connection that will result into sudden high current, then this circuit breaker, the second circuit breaker here, will trip off like this. Once that happens, power will not reach the inverter, so inverter will not get damaged. So we have double protection for the battery, for the inverter, so that the system can run smoothly when there's any error and be protected. All right. In this installation, I'm using a second charge controller here. This charge controller is not used to charge the batteries, but rather we took power out of this charge controller from the battery because of the USB terminal that it has. You can see the USB terminal here. Can you see? Okay, you can see the USB terminal. So from here, we can charge our devices, such as the mobile devices, small rechargeable radios, and so on. So that is how the setup works. So the inverter is connected to the battery, positive to the positive through the circuit breaker, and then negative directly to the battery. Now at the back of the inverter here, you can see this plug, 13 ampere plug, is connected to the inverter to take power into the house. Once it is connected to the inverter like this, then power goes from this cable to the big changeover switch here. So the big changeover switch is to switch the power from mains to the inverter. Right now, the power is on the inverter. So in the house, when the inverter is turned on, all gadgets, including ceiling fan, television, and all sockets, will receive power immediately. All right. But this is pumping machine that pumps water from the borehole. We ensure that it's connected to the mains only, so that it's not connected to the inverter in order not to overload the inverter. So that is how the design is made here. All right. Okay. So we want to see how the solar panels are mounted on the roof. That's another important information needed to mount the solar panel correctly. In the morning, the sun rises from the east, and in the evening, the sun goes to the west to set. You can see the sun now going to set. So these are important information needed for solar system, solar renewable energy system. Many engineers will install their solar panel facing the sunrise. That is not the proper way. The solar panel needs to face the sunset. The reason being that the sun in the morning around 7 or 8 will be gradually rising up, but the intensity is low until around 10 a.m. when the intensity is high. From 10 a.m. to 12 noon, the intensity will be high, but at 12 noon, the sun goes to vertically overhead, and after then, the sun begins to go to the sunset. From sunset, from 12 to 4 or 5 p.m., the intensity is so high, but the period between 12 and 5 p.m. or 12 to 4 p.m. is longer than the hours between 10 to 12 noon. For that reason, when you mount your panels and you face the sunset, you will get longer sunlight energy captured by the solar panels. So this is an important information that it needs to be considered, especially when you have a limited number of solar panels like here. So the best option is to mount your solar panel to face the sunset as we have now. Right now, this solar panel is receiving high intensity of sunlight because the sun has gone to the sunset from around 12 noon, and this now is around 3 p.m. We still see sun touching the solar panel effectively. If you had mounted them facing this side, the sunrise, then in that case, by now, solar energy will not touch the solar panel high enough. It will be less energy reaching the surface of the solar panel. So that is important information needed. Now, if you look at these panels mounted here, you will see a cable coming out under the middle panel and going into the rooftop there. So as the cable enters there, it goes into the roof in the ceiling, and that is the cable that comes out into the house. Now, briefly, depending on the number of solar panels you have, the cable size is not always the same. For this small installation, we use 4 mm cable, 4 mm square 2-core cable for the solar panel to connect the power from the solar panel to the solar controller inside. Okay. Now, when you have multiple panels, several panels being connected, you will need higher cable size such as 6 mm, 8 mm or so. But for small installation like this, you may use 2.5 mm or 4 mm. This particular installation, we use 4 mm cable for the connection. It's very important. When the cable is lower in size than the current that it will take, then it will cause overheating and eventually may catch fire. So that is very important to note. The cable size must be of the correct size in order to be effective to bring the current from the solar panel inside. One important information here is that you need to realize that solar panels does not have any controller with them, and the energy being extracted from the sun goes up and down as the sun, intensity goes up and down. When the sun is so high, it brings in maximum current, and when the sun goes low, the current going inside is reduced. And that is why you must use a solar charge controller to take care of all these up and down of sunlight rays on top of the surface of the solar panel. So the solar controller extracts the needed energy at every point in time, whether the sun is high or low, and directs that energy to the battery to charge the battery. So the solar charge controller does a lot of work. It protects your battery. Then it also ensures that the battery is charged properly. And then also, when there is a rainstorm in the night, we also extract the solar panel and send energy into the house. But at the night, there is a protection also that is designed with the solar system, so that at night, the power from the battery will not come back to the solar panel, and the solar panel will be now using the power as load on the battery. That one is also there. So this solar system has been installed now for 4 years and is still working fine. So don't forget to like and share this video. Make your comments in the description box. You can also reach me if you want a professional job like this for your solar system. I'm available to carry out a professional job for you. So thanks for watching this video. Until another time, bye.